is divided up into plates. Something that we need to talk about because we got a little confused on this yesterday. Right here we started off with coloring all of our oceanic, what color? Oceanic crust is what?
Blue.
Okay, because the ocean is blue. And then our continental, what color did we color them? Brown. So our continental crust are brown. All right. So basically what happened to the earth is kind of like what I've done with this cup. Yesterday I dropped this cup and it broke into pieces, right? And I can put the pieces back together, and when I put the pieces back together, what happens to my cup? It reforms. But it's still very weak at wherever the breaks are, right? So if I put it back like this and I glue it here, chances are this is going to break again right there where it's broken already, right? Because it's a weak point. So that's kind of like what's happened to our Earth. Our Earth has all these plate boundaries all over it, and those are the weak points. That's where we're going to have changes happen to our land, is at these breaks. All right, now my plates are going to move based on what? What's happening inside our asthenosphere? Convection currents. So what happens is that magma hits that 900 degrees there at the bottom of the outer core, and it goes where? What happens when it hits 900 degrees? It goes up because heat rises, right? We talked about this. Then right underneath our crust, it's 700 degrees. So what's that magma do?
Go down.
It cools and goes back down, and it creates that convection current. So what's happening at these breaks is basically all that's happening is where that earth is sealed there, I'm giving it pressure, and it's building up pressure till that break moves again, right? So just like here, if I was to super glue this back down here and I pushed, it's eventually going to break right there again, and it's going to move where it's already been broken. So that's what happens with my Earth's crust. Now, not all the crust are made up of one type of, or not all the plates are made up of one type of crust. When I look at my North American plate, look, it starts in my Atlantic Ocean, right? Look up here, please. It looks at my Atlantic Ocean, and it breaks here. But look, it's made up of two types of crust. What crust are made up on that North American plate? Oceanic, continental. Yesterday I kept asking some of my classes, and they just kept saying continental, continental. Just because it says North American plate does not mean that I'm only talking about North America. That whole plate goes wherever that break is. All right, so that's what I'm trying to get y'all to understand with the mud. This is one plate boundary. All right, then I have other plate boundaries, but together it makes the earth when they're all together. So when I'm looking at question number 1 down here, and it says, what type of crust are found in the North American plate? I literally just look at this plate. I have land, and we call that what type of crust? And then over here, there's blue, that's oceanic. And then there's where my break happens. So everything over here is my continental plate. You've got to pay attention to that. All right, or not my continental, I'm so sorry, my North American plate. You've got to pay attention to what all is in that boundary. All right, so that's number 1. Look up number 2. What does it say? Somebody read number 2.
What two land masses continents compose the Indo-Australian plate?
Okay, so I'm looking down here at we put the Indian Australian plate. So let's think about that. I want to know what 2 continents make up this plate. Well, I got to find 2 brown spots. I have this land, which is called what? Australia. And up here, it's called what? India. So I have India and Australia. Do you see how I had to do that? I had to look at that whole plate, and I had to find where's the 2 brown parts. I have I have Australia here, I have India up here. Write that down for number 2. Or check that you have that answer, because some of y'all got to get started yesterday. Question 3. What's 3 say?
What do you observe about all the landforms on the map?
Okay, let's look at my landforms. It says I have mountains and volcanoes. Where do I see these mountains and volcanoes happening at? Are there any mountains and volcanoes in the middle of the Pacific Plate? No. Where do they all happen at?
On a continental crust.
Somewhere with continental crust. Okay. What else do I notice?
They're like towards the edge, kind of.
So they have to be towards the edge, towards the plate boundary. I'm not going to see it right here. I'm going to see it here along the breaks. So what can I infer then? Any changes that happen to the Earth because of these plate boundaries, where are they going to happen?
Between continental and oceanic.
Not always between continental and oceanic, because I'm going to have some right here. This is going to give me my mid-ocean ridge.
Between two plate boundaries.
It's going to happen right there where those plates hit, aren't they? So that's what I can infer then, or observe, on number 3. My landforms happen right at the plate boundaries, because I have to have 2 types of crust taking place. Now, is this the only reason anything on my Earth is going to change? No, because what else do we have that changes the Earth?
Catastrophic events.
We have catastrophic events, we have tornadoes, that's going to change things, we have hurricanes change things, earthquakes change things, but what else happens? Don't we have weathering and erosion take place? Is that going to change some of my land features? So then I'm going to notice that other things that are happening inward. Now we have drilling that happens, that causes little shifts and little mini earthquakes to take place too, because we've created now a gap there underneath my crust and stuff. So there's different things we do. But these are the ones that are happening because of my plate boundaries. All right. Question 4, what's it say?
How does each type of land feature relate to the plate boundaries?
Okay, so let's think about this. If my plate boundary is happening here on land, if I have 2 lands coming together, what is it going to give me?
Folded mountain.
Folded mountains. So depending on what happens and which way the plate moves, that determines what land feature, right? Let's look over here. As I look at the Nazareth plate and the South American plate, look at South America here. What's happening?
They created mountains.
What kind of mountains are those going to be, though?
Wouldn't that be like a volcanic island?
Not island, because island has to happen in water, remember?
Volcanic mountain.
Volcanic mountain. Why is this one a volcanic mountain?
Because it's along oceanic and continental.
But it's happening for a mountain. It has to happen where? On something with the continental crust. So this oceanic is going to go down underneath. It's going to create more magma, volcanic mountains right there. All right? So that's number 4. How does it relate? So what land feature, how does it relate? It determines what the crust is doing. So if they're coming together, I'm going to get some kind of mountain, either volcanic or folded, depending on what type of crust I have. So just paraphrase that how you can. On 5, is there more than one type of crustial feature found in the same location? So is there somewhere where you see more than one feature? Well, we're looking for mountains and volcanic mountains. Do you see that anywhere?
On the North American plate.
Okay, so we have some volcanic mountains. We have some just mountains. So that'll work, right? So we can say yes to that. There's other places. It says what might cause each crustial feature to form. What causes our place to do anything? The convection current, and what does that result in? The shift in the plates. So convection current in the mantle, or in the asthenosphere, if you're really good at spelling, causes the plates to move because it's building up that pressure. Just like with that cup, if I super glue it back together, I'm going to build up the pressure until it breaks again at that point. And then 7.
Wait, what do we put for number 6?
Convection currents of the mantle causes the plates to move.
Did you get it? Okay. 7. Why do you think most I'm so sorry. Crustial features occur along the plate boundary? Didn't we already answer that? Why do they happen along the plate boundary?
Because of the convection current.
Well, why would they happen there at the boundaries?
That's where the plates are moving.
That's where they're moving. That's where I'm having my action take place, right? If I'm moving here at the plate, right here in the middle of Africa, is anything really going to change there?
No.
No.
Change along the boundary.
It's going to change along the boundary because that's where my movement's happening. That's where they're starting to either shift together, slide past. That's where all the work's happening. All right?